So generics exist to solve a very specific problem, which is that programmers are great at shooting themselves in the foot. So it's not just programmers, it's people in general. We're pretty bad at just trying to maintain a whole bunch of stuff in working memory and remember a bunch of rules and stuff. So we're going to show you what happens when we don't use generics, other than a bunch of warnings, as I had previously mentioned, right? So I'm going to go ahead and switch this to an array list just because this is a module about array lists. So this is just simply a way to create a new empty list, right? And we can go ahead and print it out. Unlike the arrays class, it will just actually print out rather than printing out a memory location, which is kind of super useful. And we can put new things into a list, and we'll go into more detail about how specifically this works and the different variations of it by doing add. So right now, because it's a list of unspecified type, we can add anything we want to it. And this is the way it worked, I think, prior to Java 1.5. Just basically you could add anything you wanted to it. Thing list.add thing list.add anything list, and we can just keep, and you get the idea. One fish, two fish, red fish, copyright notice from the Seuss estate. Right? So now so basically we've added all these things to our list and we print it out and it just works, right? It gets added in the order that we added things to it, right? So we can totally, and otherwise it's just fairly straightforward to work with these things. Let's go ahead and create a for loop to see how this works. So more detail about how the for loop will work later, but it works almost the same as an array. For list, actually right over here, there's got only one minor difference. For int I is equal to 0, I is less than, now this is of course going to be the most maddening thing. This is the one thing I truly hate. Yeah, that's a bit of a strong word, but I mean, hey, it does the job about Java, right? If you want to know how big something is, right? If you want to know how big something is, if it's an array, you would use dot length, no parentheses. If, on the other hand, it's a string and you want to know how big it is, you use dot length with parentheses because it's a method. And of course, if it is any type of collection, such as a list, then you use dot size with parentheses. Why we have this, we have three different things and three different ways of doing this, I don't know. Maybe somebody who's much more knowledgeable in Java will eventually watch this video and be able to let me know why. But all I can say in this is that it's not every language is like this. For instance, if I want to know how big anything is in Python, I just simply do that. I just throw the thing into the len function and it gives me how many things are in it. But anyway, that's it. So since we're dealing with a collection and a list is a type of collection, it's a way of organizing data, we just use list.size to get how big it is rather than doing list.length or array.length, right? Now, if I wanted to get, if I wanted to get something out at, from here, right? So I'm just going to put object here for a second, as opposed to a string. More on that in a second. But an object, by the way, what can that hold? Well, it's the superclass for everything, so it can hold anything, right? If list was an array, we'd get something out like this. We'd say list sub I, the I thing in the list, we can store it in here, and then we can print it out, right? But a list is not an array. So instead, what we use is the get function, which serves the same function. So list.getI will get the thing at the ith index. Again, more on this later. We are going to go over the methods in much more detail in the next video. Just simply follow here. But notice that I used O, right? Thing, one, anything, one fish, two fish, red fish. Copyright notice, right? So we've went ahead and printed them out. So one thing, so here's the thing. We know that I added a bunch of strings into this, and this list is only made of strings. But as far as Java knows, we could have put anything we wanted in here, like list.add 5, right? So it just doesn't know. So we run it, and now it does thing, anything, one fish, two fish, red fish, right? And then 5 at the end. Also, interesting, 5 is a primitive, but we're storing it in an object? I thought you said those things were different, primitives and objects. There's videos about that. Yep, things are going to get weedier, so don't worry about that for right now. We will go over that one in a small video about wrapper classes. But for right now, notice that basically, even though we know that all the things in this list are strings, if I try to say string s is equal to list.getI, the I thing in the list is a string, it's saying, hey, I want a string, but what you're giving me is an object. And the reason it's saying so this list.getI is returning an object, even though it's full of strings. And the reason is that the list can hold anything. It can hold multiple distinct types. So I'd have to go over here and say, actually, trust me, this is a string. If I know it's a string, I'd have to cast it to a string so it doesn't give me an error anymore, right? And then if I wanted to say, but here's the issue. If I do list.add accidentally and add in 4, so let's go ahead and run this. Boom, 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 boom. Get all the way through, and it says, hey, you can't cast a integer into a string. You can't change an integer in integer, right? That was that utility class we looked at. Cannot be cast into a string. Oh boy. So generics exist to solve this problem. The first thing that we should note is that a lot of times when we create lists, the list will hold basically only one type of thing, ever, right? When you make a list, typically you don't mix numbers and strings. You typically will just make a list of strings or a list of numbers. The other thing is that if we can enforce that only strings will be in this array list, then there's no need to cast. Then we can, if we enforce that just strings are going to be in this list, then we know that strings are just going to be in the list. So let's go ahead and see how that works. So to say it's a list of a specific type, we use diamond notation, or, well, rather we'll use diamond notation over here in a second, but we use a generic. List less than string greater than, or rather list of string. Right? This is saying it's a list of string. That's all it is. It's a list that only holds string, and it's a new array list of string. And now notice what happens over here. If we go thing, anything, one fish, two fish, red fish, copyright notice, right? Once we try to add 4, it will say, hey, that's an error. You can't add an integer to a list of strings. Right? In fact, if we look at the add method now, when we go to add, and you can go back if you need to, it says add a string, saying that you can only add a string. In fact, if I were to do this and swap it to integer, which now, right, which is the way we would add a list of ints, more on that later, and I would add list.add, notice that it changed to integer. You might be going, what's the difference between an int and an integer? The integer is a wrapper class for an int. And as we'll see in a secondary video, a wrapper class is just simply used to basically, is basically used whenever we need to use an object instead of a an object instead of a primitive, because we can't make a list of ints. Basically, so here's the rule. You can put anything you want into the generic. And there's also some complicated stuff we can do. We can say basically it's a list of bump extends, and we'll learn more about what this means later on. But you can put anything you want in here so long as it's not a primitive. So because you can't put in primitives, we have something called wrapper classes, and Java basically will convert and deconvert, or box and auto box and auto unbox a primitive to its appropriate wrapper class. So you can automatically convert ints to integers, doubles to capital D doubles, characters to cars to capital C characters. And that's actually pretty much everything I needed to say about that. So I guess we don't need a secondary video on that. So let's go ahead and go back to string and see now what we can do with casting. One thing also that I've mentioned in the overview video, you can just use diamond notation over on the right. You don't need to actually write list of string twice. Once on the left suffices. So now if I do for int I list.size, right, we are enforcing that this is a list of strings. You can't add anything that's a string to it. And now we can go, or anything that's not a string to it, list string s is equal to list.get. We get the ith item, and no warnings, no errors. Just .get, and notice over here it says it would return a string, right? If it was a list of integers or something else, it would return that type. So generics basically keep you from accidentally using some kind of incompatible type. They also make it easier to organize your code a bit. The way we create something that needs a generic is that you basically say public class, and then you would put in the generic. It's basically saying this is the symbol I'm going to use for a generic when I'm writing my class. So let's go ahead and just write something very simple. A box of something, which will contain a box. All it will do is that we will have a constructor that, let's go ahead and do, let's see. So it's a class, and boxes will just hold something inside of it. So we're just simply going to call the thing inside of it thing. So, and I'll make it private, and then we will do a, and then alt insert constructor, yes. And then alt insert getters and setters. That's all we really need. In fact, we just need the getter. So that E kind of looks really weird. Not going to lie about that. It does seem pretty weird, especially the first time you take a look at it. So private thing. So what the heck is E? Well, the way you can view it is a variable that when we instantiate box, this is going to get set to whatever is in the diamond brackets. So over here, a box of integer is going to hold an integer. So box of integer box1 is equal to new box. And since it's an integer, we enforce that it's going to take in 3. A box of string box2 is equal to new box this, right? And notice that this one took in a string, this one took in a integer, right? And it's not going to work if I try putting this in. I don't think. Let me actually check. Oh, right. Diamond notation is needed for it to start getting mad at me. It's saying, hey, what type did you want again? You wanted an integer over here? It can't infer arguments. It's saying you wanted an integer. Well, you can't put a string in an integer box, right? But what happens is basically, notice that I've put integer in here. So when we create this class on the fly, in all these e's get replaced by integer. Now e could be whatever I want. It could be something like this, generic. It doesn't even have to be in all caps. But basically it would work just as fine if I did this. Right? Seeing the lack of errors. Why do we use E? E for element, which is what we're going to be seeing because a lot of our collections are made of elements. We'll also see T for type, K for key, and V for value. We'll also see V and E used for vertex and edge, but that's much later when we're much more comfortable with these things. So your homework for ArrayList, by the way, will be going over and creating a bunch of static methods, which are different. No worries there, though. I've got a pretty good write-up on how to do that. So with that, let's go ahead and see how we actually use lists.